Today we've got a Rheem rooftop unit. It's either 8 or 10 tons. It's a two-stage system. And what I can see already, just looking in here, is, see that? The suction line's iced up. Going back to the compressor on this one. The other one offhand, but my guess is we're just we're low on gas on the system, possibly on both compressors. The owner hasn't had this serviced all summer long. I guess he was trying to save money, but now I have to pull it apart and take a look at it. It's kind of nice they put access ports for the gauges right on the outer surface of the unit. Lower section. Take a look at the evaporator coil. Okay. Here's your our problem. Let's see. See what that is? It's a piece of the belt. The belt's missing. Oh, there it is, way in there. And you have a broken belt. And the evaporator coil, oh boy. Look at that, looks like Winter Wonderland. It's all laced up. Solid snow. Alright, I'm gonna have to shut this unit off. Now this is a nice disconnect. This is a beautiful disconnect. I love these disconnects. Look at that. I don't have to pull a plug out. That's perfect. Okay, let's take a look at this guy. It's gonna be fun getting this Saturday today. Oh boy. Look at that. If you can see. This is why it should be serviced once in a while. They didn't. Things got cracks in it all the way down. They were just waiting to. Must have been making noise at least. Look at this, chunks missing out of it. Alright, let's see what we got. It's a B51. Let's see. Gotta run around town looking for this guy now. Okay, I will be back. Had to button this up. Okay, it's Monday morning. I wasn't able to get belts on Saturday. My local suppliers are all closed, and I went to AutoZone. They didn't have this heavy belt. This is a big 5L belt. What I did was I bought 2 of them, made by Browning. It's kind of interesting. Down here in the corner, Emerson bought Browning. Emerson just recently, I just found that they bought rigid tools too. They seem to be buying everybody. They bought Copeland. They bought Alco. They seem to be buying up everything. It's a good thing though. Okay, I have to get started on this. Okay, my adjustments, focus in here. My adjustments are here. There's a slot this way so that the motor will go in and out. So it looks like I have to loosen up 2 bolts over here and 2 bolts on this side, I'm sure. And then I can adjust it. What's important on these pulleys is that this surface and the surface of the pulley in there, the other pulley, let's see if you can see that better. There we go. This surface in here, it's on the same plane. If they're not on the same plane, then the belt's gonna come off the pulley on one end or the other. So now you just have to do some loosening here. I don't know if I can get this. Let's see. Nice big 9/16. This is where you want to be careful. This is where you cut your knuckles when it loosens like that. As I was pushing on it, my alarm bell was going off in my head, you know, watch my knuckles. Okay, let's get the small end first. See that? Okay. Now it's resting on the belt. Now the tightness of this is important. You're supposed to tighten it up. You're supposed to be able to twist it back and forth and have a little bit of play in it. You don't want to make it so tight that you ruin your bearings on it. Now the other thing too is this belt will stretch. So if whatever I tighten it up to today, a week from now it'll be a little bit slacker. So I'll tighten it up a little bit on the taut side, not over tight. Now this cradle is pretty nice. This setup, it goes in and out like that. and it's fairly easy. Some of them you have bolts, and you have to tighten for 20 minutes, and this is very simple. The tightment is right there. I just have to tighten up this screw, this bolt, that one, and on the other side also. That's fairly easy. This is one of the easier ones I've done in quite a while. You have to respect the people that engineered this. Some people engineer stuff and you don't know what they did for a living before they engineered it, but whoever engineered this did this before. That really was one of the easiest ones to tighten up. See, it's taut, but not too tight. What I'll do is I'll put my amp probe on the motor to check it before I start it up. And the bolts to tighten up are over here someplace. Here we are. Now there's a lot of vibration in this, so you do want to get these pretty snug. Okay, I'd say that's pretty good. Now, by the looks of it, it looks like it's 3-phase, which is fine. And everything's turning. I don't seem to have any broken vanes. Sometimes you'll come on a job and the squirrel cage in there will just be disintegrated and all twisted up. And that's a pain. You have to change bearings, a new shaft. It's a lot of work. Okay, let's see. Okay, my nomenclature is down here. And I'll have to, I don't know if we're focusing or not on it, but let's see. I don't know if we can see this or not, but the amperage A, it's 9.0 to 8.2 slash 4.68, I think it says 4.6. So the slash differentiates between 440 volts and 208 volts. The 208 volts will be the higher amperage. The 440 volts will be the lower amperage. So our amperage on this motor at 230 volts, 208 volts, 3-phase, is 9.0 to 8. I think it's 8.2 if I'm seeing that correctly. It's a little difficult to see that. So got 3 wires. You can use any one of the 3 for to check it. The amperage should be pretty consistent across them. Okay, just set up on amps. And I'm on. Now if I'm lucky, when I turn the power on, it'll go on fairly quickly. So let's see what our amps does. You can see that okay. Alright, let's turn it on. Looks good. Everything sounds good. The motor's good. Pulley looks pretty straight. Let's see. little bit, but that's just because of the rubber. But the pulleys are nice and sturdy. Means that the bearings are good. That looks fine. Okay, now it's time to check out we have 2 compressors in this unit. We have 2 systems here. So I'm going to check them both out. One of the compressors isn't working. And it hasn't worked all summer apparently. It looks like it hasn't worked all summer, or maybe it didn't. I'm not sure. Probably one system's probably low on gas and off on its pressure control. That's what I'm thinking at this point. Unless a fuse blew or something like that in the unit, or a contactor might be bad. But I explained to them it's like 65 degrees out today and it's almost October, and they've been getting by all year on one of the compressors all through the summertime. Put a strain on that compressor. They should have had this system checked out, earlier this year, but they were trying to save money, I guess. And the one compressor was just keeping it manageable in there. So what I said to them was, rather than putting gas in the other unit and getting it going, spending that money on it, it might be better just to wait on the second compressor until next May, and then we'll come up here and get everything up to par 100%. What I'll do today is I'm going to check the 2 units in the SNART 22 system. If one system's low on gas, the compressor that's running is low on gas, I'm going to move gas from the second compressor into the system and just leave the second unit idle, just because it's almost October. And that way it'll keep the bill down for them a little bit. They were happy about that, because I'm sure the one compressor will take care of the store. This system's got 61 pound suction and 214 head pressure. That's about right. So you shouldn't have to put much gas into that one. The system that's not working here. I've got 132 pounds head in suction. Compressor 1 and cooling compressor 2, and the coils both look like they're pulled in. Now why isn't the second compressor running? That's the question. Let's see if I can put you guys like this. 206 volts. I believe that's the blower. And this is cooling compressor number 2, which is running. 209, 209, 207. And we're good. Across the coil, and the wire's going to I see what they did here. Oh, they ran the line to the bottom of the coil here. On this and the okay. Yeah, L1 and L2 and L3 on the bottom of the coil, and T1, T2, and T3, the load, are coming off the top of the coil. So let's check the amperage going to the compressor that's running is 6-7 amps, which is not bad. 7 amps. I'm sorry, that's the blower coil. This is the compressor that's running. We got 13 amps for the compressor that's running, and we have no amps for this compressor. So now we have a problem between here and the compressor. Because let's see if we have the voltage. Might have a bad contact there where I'm not getting 3 legs across. I might be only getting 2 legs and 1 leg is open. And the way to check that is we can do it this way, top and bottom. Okay, I went top and bottom of the coil here. I mean the contactor. And if one of them was open, it would show voltage here, because voltage would be going around and coming back here. But since if I put them both my probes on the same point here, I would get no reading. And if this was connected, it would be like the same point, and I have nothing there. So let's check the voltage across the top. Is I got 210, 207. 212. That's how you check 3-phase voltage. You have to go from one terminal to the next, like that. That 210, and then that one terminal to the other one, 207, and then this terminal back to here. And I have 3-phase going to the compressor. That compressor should be running unless there's a high pressure safety reset or something in between here and there. So let's go check that compressor out, see why. Might have an open winding on it. Let's see. What I'm going to do now is take the 3 wires off the compressor. On a Squirrel, the rotation is important, so I'm only going to take 2 of the wires off and leave 1 on there just so that I get them back correctly. Put it on my ohms. Not to lose that screw. Just put it back in place. The sun's getting hot. Now let's see. Listen to this. I'm going to put these probes together, and you can hear my meter make noise. Okay, that means I have a completed circuit. So I'm going to go from one terminal to the next one. I don't hear anything. And this terminal to here, and I hear nothing. It looks like our winding is open in there really bad. The wires go through the wall here inside the compressor, and then through the motor winding and back to another terminal. And somewheres in the link here, it all fried off. So she's kaputski. We need another compressor, but I'm sure they're going to wait until the springtime. But what I'll do is, these numbers are fading pretty fast. I don't know if you can see that. I can't see anything on there. Luckily I have another compressor here, and I can just barely read the numbers on it. And that's what I'm going to do. So I'm going to take these wires off and tape them up, and then get the system running for them. You know what I want to do is, if this is a burnout, you can smell it. It'll be a nasty smell. It's not good to smell, but I'll be able to tell if it doesn't smell like it's burnt out. It smells normal, which is surprising because usually when the wires are apart like that, it's usually a bad burnout. Okay, let me put this all back together, and I'm going to tape these up. Put electrical tape on these so they don't short out. I could probably pull the wire off the contactor. Well, it's only going to run for another, it's almost October, it's only going to run for another week. So we'll do this job in the springtime, I'm sure. Okay. Okay, I'm just about done here on this job. I left a spare belt in here so that next year when this happens, or the year after, there'll be a belt here. Unfortunately, they had to go through the weekend without air conditioning because we just didn't have a spare belt in this unit. And they're not that expensive, so I left it up there. But it's a good Rheem unit. And I just have to put the cover on it, and then I'll be all done for this job. Later, guys.